So to solve example number 3, we have to know that cosine of theta is negative 5 over 13, and the terminal side is in quadrant 3. So that means somewhere over here, there exists a point where x is negative 5. And where I get that from is cosine is the adjacent over the hypotenuse. In the xy plane, that's x over r. And because it's in quadrant number 3, we know that the x value will be negative and the y value will be negative. And so then my radius is 13, and then my x value is negative 5. Now we could go through and do the Pythagorean theorem and solve for y and then do it this way, but we could use a different version of the Pythagorean theorem, which is sine squared of theta plus cosine of theta squared equals 1. And so on this next line, I would say sine squared of theta, or sine theta squared, however you want to say it, plus whatever the value of cosine is squared. And all of that equals 1. So then on the next line, when I square this, I'm going to get sine of theta squared plus, remember that when you multiply a negative times a negative, it becomes a positive. That becomes 25 over 169, right? So over here to the side, negative 5 times negative 5 over 13, when you multiply straight across, becomes a positive 25, and then 13 times 13 is 169. All right, so there's that. And then all of that equals 1. Now, I made a mistake earlier when we tried to do this and we ran out of time on Thursday. I put a minus sign here, and it should have been a positive sign. So now what I have to do is I have to subtract 25 over 169 from 1. Well, this is easy. Those cancel, and I get sine of theta squared. And now this 1 minus 25, think of it like this. 1 minus 25 over 169. I need a common denominator, so I'm going to take 1 and convert that to 169 over 169, yeah? Is that the same as 1? So when I do that, this is where I made my mistake on Thursday. 160 minus 25 is 144. All over 169. So I've got 144 all over 169. Now, it asked me to find sine. So when I go to find sine, what I need to do is take the square root of both sides. Now, normally, when you take the square root of something, you do the plus or minus thing, right? But because I know that sine represents y over r, and r has to be positive, that my y value or my sine value has to be negative. So in this particular case, we're going to take the negative square root. And when we do all that, we'll get sine of theta is equal to, what's the square root of 12? I said the answer. The square root of 144 is 12. And then the square root of 169 is 13. And so remember that this is y over r, and that makes sense because we knew that r was equal to 13, but now we know what y is. Y is actually equal to negative 12. Well, lastly, we got to do cotangent of theta, which is the reciprocal of tangent. Tangent is y over x, so this would be x over y. So that would be negative 5 over negative 12. The negatives cancel, so it's just positive 5 over